Hi, hello everyone. Today our chapter is Chemical Bonding Part 1. In this, we are going to know about interaction, chemical bond, types of chemical bond. In that type, we are knowing about ionic bond. Okay. Then formation of ionic bond in sodium chloride. Then formation of ionic bond in magnesium chloride. Then formation of ionic bond in calcium oxide. Okay. First, we'll go to interaction. See, nowadays everything in this world wants stability. So in the case of atoms also, they also need what? Stability. Okay. Like how it is inert gas, they are very stable. They have the outermost shell very stable. Like that, all the atoms, they want to be a stable atom. Okay. Helium has 2 electrons, that is duplet. If they are having 2 electrons in the outermost shell, they are known as duplet. And other inert gases have 8 electrons, that is octet. If they have 8 electrons, they are known as octet. Since the atoms of inert gases are very stable, we therefore conclude that atoms having 8 electrons in their outermost shells are very stable and unreactive. See, inert gases have 8 electrons in their outermost shell and they are stable. So we conclude that any atom which has 8 electrons in their valence shell, they are stable. Okay. Therefore, to attain stability, atoms also tend to combine chemically. So atoms, they combine chemically by the redistribution of electrons. There will be a sharing of electrons in the outermost shell so that each atom attains the stable electronic configuration. That may be duplet or octet. Duplet is 2 electrons in the outermost shell. Octet is 8 electrons in the outermost shell. Okay. Here you can see in the table, there are the inert gas, helium, neon, argon, krypton, xenon and radon. They all, helium has 2 electrons in the outermost shell. And neon has 10, like that. See, they are continuing the valence electrons. Okay. Helium has 2 electrons in the valence shell. Neon atomic number is 10, but the valence electrons is 8. And remaining all the inert gas have 8 electrons in their outermost shell except helium. Helium has 2 valence electrons. Okay. Next, during the redistribution of electrons, a force of attraction develops between the atoms. See, the atoms want to attain what? Stable electronic configuration. So, there is a redistribution of electrons. During that time, there is a force of attraction between the atoms which binds them together to form molecules. This bond is known as chemical bond. The force of attraction between the atoms when the redistribution of electrons is happening, this bond is known as chemical bond. Okay. Chemical bond may be defined as the force of attraction between any 2 atoms in a molecule to maintain stability. This bond is formed because to maintain a stability between the atoms. Okay. Now, types of chemical bonds. In this, we have 3 types of chemical bond. One is ionic bond. Ionic bond is also known as electrovalent bond. Then covalent bond, it is also known as molecular bond. Then coordinate bond. Coordinate bond is also known as dative bond. In this part, we will know about ionic bond. Okay. The chemical bond, this is formed because of the transfer of electrons from one atom to the another atom is known as ionic bond or electrovalent bond. There is a transfer of electrons from one atom to the another atom. For example, sodium chloride, potassium chloride, magnesium chloride, magnesium oxide, calcium oxide, ammonium chloride and calcium chloride, etc. Okay. Next, an ionic bond is formed when a cation transfers electron to an anion. See, cation will transfer the electron to anion and ionic bonds are stable. Okay. Why they are stable? Because there is a transfer of electrons from one atom to another atom so that they attain their stable electronic configuration and thus they are stable. Okay. Next, formation of ionic bond in sodium chloride. We'll see in sodium chloride how the ionic bond is formed. Okay. First, we'll take the electronic configuration of sodium 281. One is the valence shell. In the valence shell, they have one electron. Okay. Then sodium atom donates that outermost electron to the chlorine here. Okay. Now we'll take the chlorine electronic configuration. They have 7 valence electrons. See, the electronic configuration of chlorine is 2, 8 and 7. The valence shell have 7 valence electrons. See, they need only 1 electron. So, that 1 electron is given from sodium to chlorine, so that sodium also attains stable electronic configuration and even chlorine also attains stable electronic configuration. The chlorine atom takes 1 electron from sodium atom to form a negatively charged ion, that is Cl minus. Ionic bond has formed a sodium chloride molecule. Okay, this is how the transfer of electrons is from sodium to chlorine. Okay, see here you can see sodium has 1 electron in the valence shell. It is giving that to chlorine atom. Okay, then this is the sodium ion and chloride ion. Sodium chloride is thus formed. So this is the electron dot structure of NaCl. See, Na having 1 electron in the valence gives it to the chlorine, which has already 7, and after giving that it becomes 8, and so the NaCl is formed. Okay. Then formation of ionic bond in magnesium chloride. Okay. Magnesium forms ionic bond to Cl by donating its valence electrons. Okay, it gives valence electrons to 2 Cl atoms. Okay, the electronic configuration of magnesium is neon 3s2. So that magnesium has 2 electrons in their valence shell. So it gives to that 2 electrons to chlorine 2 atoms. Okay, it can achieve, so that it can achieve what? Complete octet electronic configuration by losing its 2 valence electrons. Okay, now if you take the electronic configuration of chlorine, they have what? 7 valence electrons and they need only 1 electron. See, magnesium is having 2 electrons, so that have to be transferred to chlorine. So it gives 1 electron to 1 chlorine atom and 1 more electron to 1 more chlorine atom, so that there is a stable electronic configuration for both magnesium and chlorine. Okay, here you can see magnesium giving 2 electrons to chlorine. See, they have 7 before and after they get 1 and that electrons becomes 8, that is stable electronic configuration. Okay, here chlorine gains an outermost electron from magnesium. Both the chlorine atom gains 1 electron from the magnesium. Okay. See, the oppositely charges of the magnesium and chloride ions attract each other and form the ionic bonds. Here is a clear picture how they are happening here. See, magnesium has 2 valence electrons here and this chlorine atom has 7 and that also have 7. See here, that 2 valence electrons is shared or transferred to both the chlorine atoms and thus magnesium chloride is formed, and this is ionic bond. Okay, this is the electron dot structure of magnesium chloride. See, the 2 electrons in the magnesium is 1 is transferred to this chlorine and 1 more is transferred to this chlorine. Okay, this is how the magnesium chloride is formed. Okay. Next, formation of ionic bond in calcium oxide. See, first of all, we'll take the valence electron of calcium. Calcium has 2 valence electron. Atomic number of oxygen is 8 and the electronic configuration of oxygen is 2, 6. That valence electron of oxygen is 6. Okay. Now, calcium loses 2 electrons and gets 2 positive charges over it. See here what happens. Calcium gives 2 electrons to oxygen and oxygen takes the 2 electrons and it attains the stable electronic configuration. Okay. so that they can attain the stability. Oxygen gains 2 electrons lost by the calcium and thus gets 2 negative. See, the electrons which takes, oxygen is taking the electrons so that they attain negative charges, and which is transferring or which is donating, they are known as, they get the positive charge. Okay, here also you can see calcium having 2 valence electrons, it donates to oxygen and there is the formation of calcium oxide. Okay, bond formed between calcium oxide is ionic bond. Calcium oxide is an ionic compound. In similar way, magnesium oxide is formed. Like this only, even magnesium oxide is also formed. Why? Because even in magnesium they have two valence electrons, and that 2 valence electron is shared to oxygen. That is similar to calcium oxide. Okay. And this is the electron dot structure of calcium oxide. See, calcium having 2 valence electron, that is shared to oxygen, and thus the calcium oxide is formed, and they both are attaining the stability. Okay. Thank you.